Welcome to another deep dive. This time, we're heading into the Siberian wilderness to explore the Tunguska Event of 1908.
Oh, yeah.
Imagine a massive explosion flattening millions of trees over an area larger than Rhode Island,
Wow.
with the shockwave detected as far away as the UK.
Yeah,
And yet,
no crater.
no crater.
It's a true enigma that has captivated scientists and researchers for over a century.
Right.
We have eyewitness accounts from 1908, some scientific papers analyzing seismic data and tree patterns,
Okay.
and even some modern theories that push the boundaries of what we thought we knew about space.
Sounds like we're dealing with a cosmic jigsaw puzzle with some pretty crucial pieces missing. Let's start with what we know for sure.
Okay.
Over 80 million trees were flattened in this event.
Right.
But here's the curious part.
Okay.
They weren't just knocked down in a simple circle.
You're right. The pattern is much more complex than that.
Really?
It's known as a butterfly pattern,
Huh.
which suggests that the force responsible wasn't a single downward blast.
Why wouldn't a single blast create a circular pattern?
Well, think about it this way.
Okay.
If an object exploded directly above the ground, you'd expect the force to radiate outwards equally,
Right.
creating a circular pattern of destruction.
Makes sense.
But the butterfly pattern suggests something more intricate occurred.
Okay.
Imagine an object entering the atmosphere and breaking apart, with fragments exploding at different altitudes and locations.
Uh-huh.
This could create multiple shock waves intersecting each other,
Oh.
resulting in the unusual pattern we see.
That makes sense.
Yeah,
So we're already seeing evidence that the Tunguska cosmic body, or TCB,
right.
might have been more complex than just a single solid object.
And that complexity is further highlighted by the pattern of scorched trees.
Oh, really?
This zone also has a butterfly shape, but it's oriented differently from the pattern of the fallen trees. It extends further east from the epicenter, and the burning is less intense along the axis of symmetry,
Interesting.
suggesting the heat source wasn't a simple point.
These overlapping but misaligned butterfly patterns really paint a picture of a chaotic event.
Yeah,
It's almost as if someone was playing cosmic billiards up there.
a very apt analogy.
And keep in mind, all of this was before the age of instant communication and rapid response.
Right.
The first scientific expedition, led by Leonid Kulik, didn't reach the site until 1927,
Wow.
almost 2 decades after the event.
Yeah,
They had to rely on often conflicting eyewitness accounts
right.
and whatever data they could gather remotely.
Of course.
These eyewitness accounts seem to contradict each other.
They do.
How do scientists make sense of that conflicting information?
It's a delicate process.
Okay.
You have to consider the context in which these accounts were given.
Right.
Some people might have embellished their stories, others might have been genuinely mistaken about what they saw.
Yeah.
Even the most reliable accounts, those collected immediately after the event, don't paint a completely unified picture.
Could you give us an example of these contradictions?
Certainly. Some witnesses described a fiery white strip crossing the sun's rays, while others reported seeing 2 fiery circles of colossal dimensions.
Oh, wow.
Some saw a single object, others multiple.
Wow.
There are discrepancies in reported direction of travel, time of day, and even the shape of the object.
So how do we even begin to piece together a coherent narrative with such conflicting information?
That's where the real detective work comes in.
Okay.
We have to compare these accounts with the physical evidence, look for patterns and consistencies,
Right.
and try to filter out any information that might have been influenced by media hype or simple misremembering.
It sounds like a monumental task.
It is.
So with these inconsistent eyewitness accounts and a complex blast pattern,
Yeah.
what are the leading theories about what actually caused this?
The 2 most prominent theories are an asteroid and a comet.
Okay.
The asteroidal model suggests that a stony asteroid exploded in the atmosphere in what's called an airburst.
But the lack of a crater and significant fragments seems to contradict that.
Exactly. That's where the cometary model comes in.
Okay.
A comet, particularly one rich in volatile ices,
Right.
could explain the lack of substantial remnants.
Okay.
As it entered the atmosphere, those ices would have vaporized rapidly,
Okay.
creating a massive explosion without leaving much behind.
As someone who follows this topic,
Yes.
you would find it fascinating that people across Europe reported unusually bright skies for days after the event.
I do.
This phenomenon, known as bright nights,
Uh-huh.
could have been caused by high-altitude dust and ice particles from a comet's tail reflecting sunlight.
It's a compelling piece of evidence that supports the cometary model.
It is.
However, both the asteroid and comet theories have their strengths and weaknesses.
And this leads us to a fascinating possibility. Could Lake Checo hold the key to solving this mystery?
Ooh!
Located near the epicenter, its funnel-like shape is unlike typical Siberian lakes.
That unusual shape has led some researchers to propose that Lake Checo is actually an impact crater. Sediment analysis showing layers consistent with an origin around 1908 further supports this theory.
The search for physical evidence must have been challenging.
It was.
What did the researchers uncover?
They haven't found large meteorites, but intriguingly, there's evidence of a dense object detected beneath the lakebed.
If there's something solid down there, could it be a fragment of the TCB?
It's possible.
Does this bring the asteroid theory back into play?
It's not quite that straightforward.
Right.
The question is whether a fragment could have survived the main explosion with enough force to create a crater like Lake Checo.
Yeah.
If it did, it would certainly complicate the picture.
So we have the classic asteroid versus comet debate.
Right.
And then this enigmatic Lake Checo.
Yeah.
Are there any other theories out there, or are we sticking with those three main contenders?
There are always those who think outside the box.
Of course.
And the Tunguska Event is no exception.
Right.
Some speculate about more unconventional causes like antimatter,
Oh, wow.
miniature black holes.
Really?
Or even a crashed alien spacecraft.
I have to admit, the idea of a tiny black hole passing through Earth is always a fun one to entertain.
Yeah.
Though I imagine it wouldn't have left much of Siberia behind.
A humorous thought, but the scientific community generally focuses on explanations that are grounded in evidence and established principles.
Okay.
There's no current support for these more outlandish ideas.
That's fair.
Yeah.
But even sticking with the asteroid or comet hypothesis,
Mm-hmm.
this event really highlights the potential risks we face from space.
Absolutely.
Yeah.
The Tunguska Event underscores that even a relatively small object can have a devastating impact.
Wow.
It's a stark reminder of the need for better detection and monitoring of potentially hazardous objects in our cosmic neighborhood.
If we go back to the eyewitness accounts for a moment,
Okay.
is there anything that stands out to you as potentially insightful?
One recurring theme in these accounts is the mention of multiple explosions or thunder-like sounds before the main event.
But if the object was primarily ice,
Yeah.
wouldn't the heat from the explosion have melted the surrounding permafrost,
Right.
leaving some kind of geological trace?
That's a great question.
Yeah.
And the answer is it depends on several factors, including the altitude of the airbursts,
Okay.
the composition of the object,
Right.
and the specific geological conditions at the time.
Okay.
It's possible that the permafrost layer was thin enough in that particular area,
Right.
or that the explosions occurred at a high enough altitude that the heat didn't significantly impact the ground below.
So the lack of obvious permafrost melting doesn't necessarily rule out the cometary model.
Exactly.
Okay.
And those multiple booms before the main event,
Yeah.
those are consistent with the Antonov spindle model.
Could you explain what a spindle model is for our listeners?
Certainly.
Okay.
Imagine a long cylindrical object like a spindle
Okay.
entering the atmosphere at a shallow angle.
Okay.
As it heats up, it begins to break apart and release energy in a series of smaller explosions.
Uh-huh.
These smaller airbursts, spread out over a distance, could account for the multiple booms reported by witnesses,
Right.
culminating in the final, more massive explosion that caused the widespread devastation.
So this spindle-shaped object,
Yeah,
potentially a comet,
right.
enters the atmosphere, breaks apart,
Yeah,
creates a series of airbursts,
right.
and then culminates in that massive explosion, flattening trees for miles.
Exactly.
And no crater.
And no crater.
It's mind-boggling.
It really is.
It is.
And reconciling all these pieces of evidence is one of the biggest challenges for researchers. We have this lack of a crater and large fragments pointing towards a cometary composition.
Okay.
But then the sheer force of the blast,
Yeah.
the flattened trees and global atmospheric disturbances
Right.
suggest something much denser.
Could we be dealing with something entirely new?
We could.
Something we haven't categorized yet?
Right.
Space is vast,
Yeah,
and we're constantly discovering new objects and phenomena.
that's a possibility we can't discount.
Right.
The Tunguska cosmic body might have been a unique type of comet,
Okay.
or perhaps an asteroid with an unusual composition that explains its behavior in the atmosphere.
If we wanted to definitively solve this mystery,
Uh-huh.
what kind of evidence would we need? Is there anything that could settle the debate once and for all?
Finding irrefutable physical evidence linked to the TCB would be ideal.
Okay.
This could be meteorites with a composition consistent with the estimated energy release.
Right.
Or maybe isotopic anomalies in the soil and vegetation around the epicenter that point to an extraterrestrial origin.
Okay.
You know, as you might have read, scientists have found microscopic particles embedded in trees and the soil around the epicenter.
What can those tiny particles tell us about the TCB?
They're incredibly valuable clues.
Okay.
By analyzing their composition and comparing them to known meteorites,
Uh-huh.
scientists can try to narrow down the possibilities.
Right.
Some of these particles contain high levels of iridium, nickel, and cobalt,
Wow.
elements common in meteorites.
Okay.
But whether this points to an asteroid or a comet is still debated.
It seems even the smallest clues aren't giving us a clear-cut answer.
They're not.
And to add to the intrigue,
Yeah.
one study found a peculiar pattern in the distribution of ytterbium,
Uh-huh.
a rare earth element in the soil.
Okay.
This pattern aligns with one of the proposed trajectories for the TCB.
It does.
So we have ytterbium hinting at a specific path for the object. Is this the smoking gun we've been looking for?
It's certainly a captivating lead.
Yeah.
However, the presence of ytterbium in this specific pattern doesn't neatly align with either the asteroid or comet hypothesis.
Oh.
It raises the question,
Yeah.
could there be another type of dangerous space object out there, something we haven't even classified yet?
It makes you wonder what else might be lurking out there in the depths of space.
It does.
Yeah.
It's a humbling reminder of how much we still have to learn about the universe and the potential hazards it holds.
It's incredible to think that over a century later, we're still grappling with these fundamental questions about the Tunguska event.
Yeah.
It really underscores the vastness and mystery of our universe.
And the importance of continued scientific inquiry.
Right.
The Tunguska event might seem like a distant event, something that happened long ago and far away.
Yeah.
But it holds valuable lessons for us today.
What kind of lessons do you think we can take away from this? Aside from the obvious need to keep an eye on what's coming at us from space.
Well, for one, it teaches us to be humble in the face of the unknown.
Right.
We often think we have a good grasp of the universe and how it works,
Yeah.
but then an event like this comes along and challenges our assumption.
It's a reminder that there's always more to learn and discover.
Precisely.
Right.
And it also highlights the importance of critical thinking and open-mindedness.
Okay.
We have to be willing to consider multiple perspectives.
To weigh the evidence carefully and to acknowledge that sometimes the answers aren't clear-cut. It sounds like the Tunguska event is more than just a scientific puzzle.
It is.
It's a philosophical lesson as well.
You could say that. It
Right.
forces us to confront our own limitations,
Yeah.
to recognize the vastness of what we know,
Uh-huh.
and to approach the universe with a sense of wonder and curiosity.
Well said.
Thank you.
So what's next in terms of research? If you were leading the next expedition to the Tunguska site,
Yeah,
where would you start your search?
that's a great question.
Yeah.
I think the focus should be on finding more physical evidence that can be directly linked to the TCB.
Okay.
That could involve more expensive analysis of the soil and vegetation,
Right.
searching for those microscopic particles we talked about,
Yeah.
or perhaps even using ground-penetrating radar to investigate the area around Lake Checo more thoroughly.
And maybe, just maybe, one day we'll find that definitive piece of evidence that solves the mystery once and for all.
Or perhaps it will lead us to even more questions.
Oh.
That's the beauty of science.
Right.
It's a journey of constant exploration and discovery.
We've certainly covered a lot of ground in this deep dive.
We have.
We've examined the facts,
Yeah.
explored the theories, and
Yeah.
even ventured into the realm of speculation.
A little bit.
What are your final thoughts for our listener today?
The Tunguska event, in all its mystery and complexity, serves as a potent reminder of the incredible power of nature and the boundless wonders of our universe.
Right.
It's a story that continues to unfold, a puzzle with missing pieces that we're still trying to find.
And maybe, just maybe, it's a story that our listener will help write the next chapter of.
Maybe.
Maybe you'll be the one to uncover that crucial piece of evidence
Right.
to make that groundbreaking discovery that finally solves the enigma of the Tunguska event.
It would be incredible.
Until then, keep looking up, keep asking questions,
Yeah.
and never stop exploring the mysteries of the cosmos.
And remember, the universe is full of surprises.
That's a great note to end on.
Thank you.
Thanks for joining us on this deep dive into the Tunguska event.
It was my pleasure.
We hope you found it enlightening, intriguing, and maybe even a little bit awe-inspiring.
I did.
Until next time, keep exploring.